Inkjet Printing Masterclass. These 6 online video presentations are created from our own experiences dealing with thousands of photographers' printing requirements, and as such is biased according to what we found to be successful. Don't panic if you miss some of my commentary. I will be covering a lot of ground in this brief presentation. You will find the complete text of this lesson below this video. Why not print it out for your study notes? Many of our customers have asked me to produce this up-to-date guide, so let's get started. Now, colour management and process control. We've got 7 real subjects that we want to deal with through this lesson. The good, the bad and ugly of colour management, basic concepts, professional colour management made easy, process control, what happens when things do go wrong, and we've got to adopt the right attitude while we're following correct colour management procedures. And of course we need feedback, because if we make a mistake we want to be told and we want to put it right for future editions of these videos. Now let's go to the first issue, the good, the bad and the ugly of colour management. If there's one area of digital printing that fills most people with dread, it's colour management. In our experience, over many years of supporting thousands of professional photographers, enthusiasts and pro studios, the best way to handle this is to make it as simple as possible, let us do most of the work, and once everything is working perfectly, keep all your settings and workflow constant. If ever your colours go out of tolerance, contact us immediately to get you back on track. A colour inkjet printer and monitor combination which is not accurate for colour and density makes your print production almost unworkable. However, if you have an accurate colour inkjet printer, at least you can produce good work from good quality origination images which don't need adjustment. Printing directly from a great digital camera image without Photoshop editing using a custom profiled inkjet printer on a good ProPhoto inkjet paper will often produce your best work. If your original images, whether obtained from film via a scanner, direct from a digital camera or obtained from an external source, needs colour and density adjustment, you will need not just an accurate colour inkjet printer, but also a monitor that gives you a display as close to your print output accuracy as possible. It's a fact of photographic life that many computer monitors in use are not particularly accurate for colour or density, or both. Even many monitors which have been so-called calibrated with an on-screen spider may still not be accurate enough for professional standard image editing. The monitor may either be too old to achieve the correct colour range or of too low a quality to accurately mimic the colour range and response curve of your images. If your budget allows, treat yourself to a good quality professional standard colour monitor and invest also in a professional standard monitor calibration instrument. Modern inkjet printers create colour and monochrome prints at staggeringly high resolutions and are able to respond to tiny percentages of adjustment. In addition, modern professional photographic inkjet pigments and dyes easily extend out to the extremities of our working colour space. Most monitors only render our images at a laughably low 72 dots per inch, but our brain cleverly interprets these low-res images as smooth continuous tone. These same monitors usually respond very sluggishly to fine adjustment applied in our image editing software, usually Adobe Photoshop, Elements or Lightroom. Tiny subtle changes to your image using this software may be seen on your print but are often not picked out by your monitor. You must be aware of this issue. Modern inkjet printers, when supplied with consistent ink, paper and data input, are stable colour devices, provided their nozzle check, which is ink flows, are perfect and reliable. Most monitors degrade in use over time. Various equipment, image editing software, operating systems and printer drivers create numerous combinations which usually work well together and make it possible to easily achieve colour and density accuracy. But sometimes things don't work out and you may need a second attempt to get a good result. Most of our computer systems nowadays are connected to the web and are often subject to external influences such as online updates to software, assaults by viruses and unwanted changes to our workflows. So whatever method we use to achieve colour accuracy, we must check that we have got good accuracy and also check periodically that we maintain it. Let's put all of the above in the category of the bad and the ugly. Now let's look at the good part. Marriott and Marriott USA have been achieving and maintaining colour and black and white accuracy for thousands of professional photographers, enthusiasts and studios for many, many years. Our equipment, software and techniques are well proven and our methods are easy to follow. And if that's not good enough, I've left the best news until the end. It's all free. Now, basic concepts. In the real world of images, there is detail, tone and colour. So let's get my little stick. This is what we call detail. So whether you can pick this up, we've got a nice high-res image on this side and we've downrated the resolution for you to see the difference. So we've got a 1/10 reduction here, 100 pixels per inch resolution, 10 pixels per inch resolution. The other aspect is tone, which we're going to go into in a little bit further detail. So you've got a very rough 2-bit tone, you've got a 4-bit tone, and then a 24-bit tone. And we hope you can actually see the difference between the various tones. And finally, we've got colour. So this is colour range or colour gamut, as we call it. And we've got various environments of colour that we can work with. A very common environment of colour, which in a lot of photographic areas is the default colour range, is sRGB. And hopefully you'll be able to pick up here on the video that we've got a fairly limited red here. But when we go over to a wider gamut, now this is the industry standard professional photographic colour space, which is Adobe RGB 1998, which we'll be talking about in detail here. We've got a better red, and in turn you'll get a better green, a better blue. All the range of colours is better. So we've virtually got three things to talk about. We've got resolution, which is detail. We've got colour tone, and finally we've got colour range. So we've got detail, tone, and colour. Those are the basics of what we'll be talking about. Now, resolution. Resolution is, broadly speaking, a measure of the number of pixels that are contained within a given area. Bit depth is an indicator of how finely levels of colour can be expressed. Colour gamut shows how broad a range of colours are available to us in a given situation. Now let's talk a little bit further about resolution. Computer monitors are almost always display images at 72 pixels per inch, which is fine for viewing at a distance of, let's say, arm's length, but inadequate for viewing at close quarters. If ever you want a shock, if you get close up to an average computer monitor and you look up close, you realise what you're actually seeing. You're seeing some very rough squares of colour. When viewing a monitor's transmitted light, your eyes and brain create an illusion of smooth continuous tone, which on closer inspection reveals a very coarse, rough facsimile of an actual image. Moving images on a monitor at this resolution fool the brain even more until you convince yourself that the moving images are of fantastic quality. That's just how we perceive it. Images being prepared for print within Adobe Photoshop or Lightroom or Elements or similar are usually sized up at between 180 to 360 pixels per inch. So we're talking about this area now, which is the print document that we're getting ready to print to go to our printer. Now they're usually sized up at between 180 to 360 pixels per inch. The good resolutions are 180 or 200 or 240 or 300 or at the maximum 360 pixels per inch. Now we don't use awkward odd numbers. This may create noise in smooth parts of the image, and it actually makes the calculation for Photoshop or Lightroom difficult to perform. So we end up with awkward numbers which create noise in the smooth parts of the image. Use lower resolutions when trying to print larger formats from smaller size files, and use larger resolutions when you require the best possible quality image prints. So for instance, if I've got a tiny little image from my iPhone, for instance, and my clients want me to print it out at, let's say, 5:7, what I will do is I will adjust the resolution in Photoshop so that it is 180 pixels per inch by 5 inches by 7 inches, and then hand that over to the printer driver, which will then bring it up to the actual print resolution of the dots on the page. Now, if I've got, on the other hand, a fantastic quality scan, and I've got lots and lots of megabytes to play with, and I've got a client that wants me to produce that at, let's say, 11:17, what we'll do is I'll resize that to 360 pixels per inch by 11:17, and that'll be a fairly sizable file, but I'll hand that over to the printer driver, and again it will make an excellent job of bringing it up to the printer resolution. Those are the two extremes, I think, of resizing. When you send your images to your inkjet printer, the printer driver upscales your document resolution up to full printer resolution, usually 1440 dots per inch or above. Now, if you notice here, I've made a mistake. Can you see? I make a very common mistake. Instead of calling it 5760 dots per inch, I've made the mistake in my rush to get these screens prepared. I've actually put pixels per inch. But it's pixels per inch when we talk about the monitor resolution. It's pixels per inch when we talk about the image resolution. But it's always dots per inch when we're trying to express the amount of dots being sprayed down onto the page. And these figures are usually a manufacturer's estimate of the emulated resolution. These figures here are fairly loose. These are accurate figures, but when it comes down to the final claims for the printer manufacturers, These are emulated figures, which I personally take with, I take them as a guide. I don't really take too much notice of them. Now, when you send your images to your inkjet printer, the printer driver upscales your document resolution up to full printer resolution, usually 1440 dots per inch or above, and uses a complex algorithm to create a dot pattern which emulates smooth tone to the naked eye. In actual fact, the printer driver applies a very complicated bit of mathematics so that it recreates smooth tone. Now, my first outrageous statement of this lesson is to never print at any time below 1440 dots per inch. How about that? We are photographic print workers for whom draft quality or super fast printing should be totally foreign at all times when printing photography. If you click on high speed, that's not too bad, as usually this means that you are simply laying down ink during both passes of the print head. So on the left hand pass you're laying down print, and on the right hand pass you're laying down print, both ways. Never forget that someone will catch sight of your low resolution prints and they will think that it is your usual print standard. I would always advise you to keep your printing to a uniformly high standard and always avoid very low resolutions. No matter what people will tell you, you are always judged on your prints. Don't ever let low quality work come out of your studio. Experiment with your higher printer resolutions and make a decision whether you can visually see the difference between a painfully slow, super high resolution printer setting or a more productive best photo or photo quality or photo RPM setting. I'm not able to give you a hard and fast rule here. You will simply have to print test on your own machine and make a judgment. Incidentally, I've always understood RPM to stand for resolution print maximum or maximum print resolution. Please let me know if I'm right in this, because I've never actually found out. Now let's have a look at bit depth. Now bit depth officially is the number of bits to indicate the colour of a single pixel. So for instance, an 8-bit per channel system in RGB is that which is capable of rendering 2 to the power of 8 possibilities of colour to 3 channels. 1 red, 1 green and 1 blue. 2 to the power of 8 is 256. So each channel here can render 256 possibilities of that particular colour. Higher bit depths increase the possibilities of colour in each channel exponentially. So a 12-bit per channel system is theoretically capable of conveying 2 to the power of 12 possibilities of colour, which is 4096. So in a 12-bit per channel RGB system, you would theoretically be able to convey 4096 by 4096 by 4096, which is over 68 billion colours. Finally, and this is as far as we need to go here, a 16-bit per channel system is theoretically capable of discerning 2 to the power of 16 possibilities of colour per channel, which is 65,536 per colour. Now, to put these staggering figures into context, most inkjet printers are capable of 8-bit per channel colour depth. Modern high quality digital cameras and scanners have CCD detectors which work in the 12 to 16-bit per channel range, and Adobe Photoshop CS image editing software is capable of extensive editing functions in 16-bit per channel. Desirable for high-end work, as I will cover in the last two lessons, Colour Print Masterclass and Black and White Printing Masterclass. Simply put, image editing in 16-bit avoids breaking up tonal graduations and vital data during image processing. We'll get into this during the last two in-depth sessions. Now, my simple guide here for ultimate quality is to capture at your camera in 16-bit. You would edit your image if you have software capable of doing this. You would edit your image in 16-bit. But then just as you hand this over to the printer, you would change the mode down from RGB 16-bit to RGB 8-bit. Now, for normal high production work, I would advise you to keep it in 8-bit throughout. You'd capture in 16-bit, let's say, but you'd hand it off into Photoshop, bring it straight down to 8-bit, and your file sizes will be much more manageable, and you will process a lot quicker. So again, for normal high production work, keep it 8-bit throughout for speed, but try to keep image editing to a minimum to keep your images clean and smooth. Now, this again is a subject that we'll be dealing with in the main masterclass lessons when we're dealing with colour printing masterclass and black and white printing masterclass. Now, let's recap about resolutions. Now, the human eye up the top left hand corner there is capable of discerning just over 10 million possibilities of colour and density in total. The virtually every inkjet printer driver is only capable of processing 8 bits per channel colour. So we're talking about this area here, which means that we have 256 steps of blue, 256 steps of green, and 256 steps of red. 256 by 256 by 256 equals over 16 million possibilities of colour and density. Very few laptop monitors truly come up to this standard. Now, when we're talking about monitors now, most good quality brand new computer monitors, whether they're Apple Mac or if PC, hopefully equipped with a VGA graphics card, are 8-bit per channel, which means 256 steps of red, 256 of green and 256 of blue, which again means 16 million possibilities of colour. As I've said, very few laptop monitors truly come up to this standard. So we've got to be aware of this if we're coming away from a standard monitor, particularly a good quality monitor, and we make the change to a laptop monitor. Now, modern professional standard digital cameras achieve a bit depth in excess of 10 bits per channel. Many sensors on these cameras are capable of 16-bit per channel. And the latest versions of image editing software, such as Adobe Photoshop CS, allow extensive working in 16 bits per channel. The desirability of this workflow for ultimate image quality, again, will be explained in my last two lessons. Now let's get into colour space. Now these are excellent diagrams. Now what we've got here on the left hand side is a very simple, it's a simplified view of the of the colour space. Now, what we've got here is the environment, the general environment of print, which is CMYK, cyan, magenta, yellow and black. So what we have over here is the limitation of the printed page. What we then have is what is becoming a pretty well default colour space for consumer quality photography, which is sRGB. And you want to be aware that a lot of laboratories out there are settling for sRGB as their default colour space because it's very forgiving and it's not at all it's not really challenging at all. Now the colour space that our cameras tend to actually capture is approaching the extremities of the entirety of the colour range that is available to us in the outside world, which is the lab extremities. So all the way out there are a lot of camera sensors nowadays that can actually capture around this area, not right to the end, but fairly close to it. And for our purposes, our industry, the professional photographic industry, has decided that the Adobe RGB colour space, that's the environment of colour that we like to work in, and we know that pretty well all of our inks and papers and printers and our equipment that associates all this can live in this Adobe RGB 1998 colour space. So this is the colour space we actually want to work with. Now on the right hand side, this is a very nice method of actually explaining the colour value, which is hue. So that's the colour wheel coming around this way. That how far out from the centre of the colour wheel is the actual amount of colour, which is saturation. So as you're getting further and further saturated, you're going further out. And the actual value, that the lightness of the colour, is ascending up this cone. And we call this the HVS cone, the hue value saturation cone, which is a nice thing to keep in your mind when you're thinking about an individual value of a colour. How bright is the colour? How intense is the saturation? And also what variety of colour it actually is. So if we've got a little square here, for instance, we can see that it's very, very bright. We can see the variety of colour that it actually occupies. That segment there is a variety of colour. And you can see how far out it is from the centre, the actual saturation. So that is a nice way of visualising an individual value of a colour. And when you put all these colours together, you're actually looking at the perimeter of colour that your devices work together to transfer from your taken image out to the final print. And we notice that we're working in Adobe RGB, and look at our poor old our print friends here. They're working in a pretty limited environment here. So we need to be aware of this, but really we need to hand over files to our CMYK friends. My opinion is we hand it over in Adobe RGB and we let them do the conversion across, but we give them, to help them, we give them an accurate colour print to give them a guide as to this conversion process. And when they're able to create the print accurately in CMYK to mimic as accurately as possible our RGB print, that tells us that, all right, it tells them that they've done a good job with conversion. That's a very, very simplified overview of RGB and CMYK. Now, the human eye is capable of discerning an extremely wide range of colours, as evolution has decided that the ability to differentiate between very similar colours is an extremely powerful survival skill. For example, being able to see a hostile animal hidden among the green leaves of a tree. So our eyes are able to outperform most man-made colour materials which we use in digital imaging output. Modern inkjet inks are generally quite good at rendering a reasonably wide range of colour, but not as much as our eyes are capable of. So the photographic inkjet printers we use are said to be easily capable of achieving the Adobe RGB 1998 colour space, provided we feed them with good quality inks and papers. This colour space is quite adequate in creating the illusion of real world colour, but it is important to remember that our eyes can actually discern a wider range or gamut of colours than this. We must set our computer image editing software, which is, let's say, Adobe Photoshop or Lightroom or Elements, to our desired correct colour space. I suggest that the current industry standard, Adobe RGB 1998, in order to render 255 levels of density across the entire range of our usable colours for the smoothest possible tonal graduations. If we get this wrong, we create harsh tonal steps in parts of our image which contain subtle, smooth graduations. A clear sky, for instance. It will show you how to do this. I will show you how to do this in the next section of this lesson. We also show here a valuable way of visualising colour and density. The HSV colour cone. Hue, saturation and value. Next time you look at a particular colour, try to visualise where that colour would appear on this cone. Describe the colour, the extent of the colour and the density brightness. So the colour is hue, the extent of the colour is saturation and the density or brightness is value. This exercise enables you to start comparing colour values in a more understandable context. In addition, the quality of the light used to view our printed images is vitally important in discerning printed colour. A pure, clean white light of 5000 degrees Kelvin is ideal in this regard, or view our prints in daylight, preferably in the middle of a cloudy, overcast day. An entire industry is out there providing you with competitively priced viewing lights for evaluating colour. Talk to your important clients and confirm which colour temperature they like to view their workflow. Try to emulate their viewing conditions. This is particularly important if your work is to be reproduced on the printed page via litho or CMYK web press process. Now I show on the left here a high-end dimming viewer which we use. We've got exactly this viewer, and actually there's a little dim around the side which enables us to set the intensity of the light absolutely correctly, and that's a great advantage for us. Now that particular viewer cost us over £1,000, which is just over $800. But for normal use, I would use either of the two desk lights shown on the right. So we've got the high-end viewer over here, which I think is around £100, about just over $80. Or the smaller viewer, which again is an excellent little viewer. I think we can buy for about £50, which is about, let's say, just over $40. So these are excellent lights to do the job on the desk, but for high-end professional use, which obviously we need to follow the absolute top level of viewing accuracy. We have one of these lights. In actual fact, in our studio we have these, we have one of these, and we have many of these as well. Now let's get on to monitors now. Many higher quality brand new computer monitors Apple Mac or PC monitors with VGA graphics cards and above are just able to convey an emulation of the Adobe RGB 1998 colour space. Once these monitors get old, they progressively lose this ability, and many laptop monitors are unable to reach this colour space even when brand new. This is why we must check our monitor performance regularly against a known source. We use our own calibrated Master Colour Print, this print over here, which you can get from us easily. You can email us to technical@marriott.com or technical@marriottusa.com. Give us your full postal address and we will actually send you free of charge a certified accurate calibrated print which has plenty of reference points, particularly a good rich black, nice accurate neutrals as we've seen before. We've got primary colours, we've got smooth graduations going back, and the most important thing of the lot is that pale flesh tone. These areas are super critical when it comes to printing. If we can print this image correctly, everything else tends to fall in line. And when we've got our calibration print, we can actually download this image. It tells you along here how to download the image, and you can download this image from either marriott.com /print or marriottusa.com/print. You can download the JPEG and then view this print on your PC monitor or your Apple Mac monitor, or if you're lucky enough to have one of these beautiful high-end laptop monitors, you can actually then check the accuracy of your display. Now I show here a typical good photographic quality monitor for PC or Mac operating systems. Now in this case we show an ISO monitor, but there are plenty of others. It's not just ISO. There's plenty of other makes that are suitable. We have an X-Rite monitor calibration device in place, as you can see here. We'll be talking about that further. Personally, I use all Mac monitors which deliver acceptable colour. I also show a high quality laptop. Now laptop screens should be used with caution, as in my experience very few deliver truly accurate colour information. Now I show you this MacBook Air with its new Retina display as an example of probably the best you're going to achieve from the present laptop format. And of course the same goes for tablets. The latest Retina display from Apple is probably the best you will get at present. But remember, things are changing all the time. So this advice will very quickly go out of date. Please be cautious of this. Now let's get in to colour management. This is our first step to professional colour management made easy. It's not difficult so long as we follow these very easy steps. So the first thing to do is we must set Adobe Photoshop or Elements or Adobe Lightroom or your image editing software to the correct RGB settings. We must make sure that we're living in the Adobe RGB color space. Now this is on the left hand side. We show our selected settings for the European market, and these show European defaults. And on the right hand side we show our recommendation for the American market, which give you the pre-pressed defaults for the American market. And you can very easily get to this straight away by going to color settings in Photoshop, Europe pre-pressed defaults, and then everything else follows. So up here, working space, RGB, Adobe RGB, and from now on in, when we open up an image, it will ask us to make the decision whether we want to convert to our proper working space. My advice, which does, this is only my own experience, is that pretty well everything that comes in we want to convert to the working space. But this advice can change depending on a particular requirement of the client for a job. So we have to be a little bit careful here. But my general advice would be to always convert to the working space. All of these options are correct. We go down here because the preset that Photoshop has already set for us here, we simply select Europe Pre-Press Defaults. On this side for the American market, we go to Photoshop or Lightroom, go to RGB color settings, and we go US Pre-Press Defaults. Again, it gives us the Adobe RGB 1998 working space. Everything else is decided for us. And again, when we open up our images in Photoshop, it will ask us now, do we want to convert to the working space? And again, my advice would be the same. In most cases, I would convert to the working space unless specific client requirements dictate that we do not change the working space. If we've got a very high-end client who has specific requirements, we must do as we're told as imaging professionals. So my advice here generally is to convert to the working space. But once you've got Photoshop or Lightroom set up in this way, we've now got ourselves our image editing software correctly set for the professional photographic color environment. Now, you will usually find these color settings at the bottom of the edit menu. Often our customers phone us in to double check their RGB settings in Photoshop or Lightroom. Now this is no bad thing and we don't mind this at all. Now when we're going to create a test target for our custom profile, we have to use a new method of creating the test target. So what we do is this step 2 is we download the Adobe Color Print utility. So we print out a custom printer profile test target using the Adobe Color Print utility. Now before you do this, check that your Inkjet printer nozzle check is perfect and consistent over time. This means that your printer should easily create a perfect nozzle check at any time. If your printer produces inconsistent nozzle checks, get it serviced before committing to a custom profile exercise. Remember, we want to achieve both accuracy and consistency. My top tip here is for you to print out 3 identical targets and use the third printed version, which usually represents the best average print characteristic for production. Now the reason that we have to look at this now is that from the release of Adobe Photoshop CS5, CS6 and Creative Cloud, Adobe have taken out the facility of fully turning off color management from their printer driver interface. In its place, they've published a simple print utility, the Adobe Color Print utility, which we show on the left hand side is the landing page that you would get to if you put the words Adobe Color Print utility into the Google search engine. Number 1 result will take you to this page, and it actually explains what's happened as far as Photoshop. No color management option missing, Photoshop 5, and we've actually got a little link here, which is the link for the Mac operating system, and then we've got a link there for the Windows operating system, which takes you to a little download, and then you download the utility, and then that's what appears on your desktop when you open up the Adobe Color Print utility. We've got a test target on our desktop, and we've actually selected it here. It says please select a TIFF to print, and we've selected a test target that we've sent to a client, and they've saved this TIFF on their desktop, and we're just about to press that open button. So the stages are: enter Adobe Color Print utility in Google. That will take you to this page. You would then click on one of these little links that enables you to download the very simple utility. You open up the utility. You then can open your test target that your profiler will provide for you, and then we'll go to the next stage. Now let's go on to the next screen, and it shows you the TC 9.18 test target that we're about to print, and we've got some settings here. Now when you print out your custom profile test target, make sure you have a reliable, consistent, perfect nozzle check with no gaps whatsoever. Take careful note of your printer settings when producing this test target. You will need to repeat these exactly when you receive your finished custom printer profile back from your profiler. For professional photographic printing in colour and monochrome, a TC 9.18 test target, as you see here on the left, or higher, is in my opinion what you should use. This means that you're taking samples from your printer for nearly 1,000 colour and density squares. If you use a lower sample number, say 300 or so, you may experience a lower level of smoothness in subtle tonal graduations. For the print standards we aspire to, this is not acceptable. I show here on the right a typical printer setting for our own Epson R3000 desktop inkjet printer. I have specified Epson Premium Glossy, there we are, Epson Premium Glossy, as the paper type, because I'm printing on Marrott 265 gram Profoto Gloss. I select Superphoto 5760 DPI. Notice it mentions DPI there, dots per inch. I select Superphoto 5760 as my print resolution, and I've highlighted high speed to be on to enable bi-directional printing for better productivity. Now I keep a careful note of these settings, usually by saving them as a preset. So up the top here I can actually click on preset and I can save as. So I usually save the preset, naming it as, in this case, R3000 Gloss, and I usually put a today's date in there as well. Now I can rename this preset later on to tie these settings in more closely to my finished custom profile file name. If you're in any doubt which printer settings to apply and save, always talk to your profiler, who will want to get it right just as much as you do. Your profiler may allow you to submit more than one test target per paper type. This is called paper characterization. You print out your custom profile test target using the most appropriate paper setting. Say for glossy paper, you'd use Epson Premium Glossy setting. Then you can print another target using the next paper setting above and the next setting below this particular listing in your settings. This gives you a range of slightly different amounts of ink being laid down onto the paper. Mark up your targets clearly down the bottom outside of the image area, outside of the dotted lines, showing which one is which will allow your profiler to decide which target he will process. Now he's looking for the best Goodrich black. He's looking for the most crisp edge-to-edge colour, crisp edge to each colour, with optimum dot gain, minimal edge bleed, plus a uniformity of sheen across differing colour and densities. Generally, he's looking for the best possible ink characteristic, which is usually slightly starving the paper of ink. Now, we don't want an over-inking situation. An experienced profiler will be able to easily recognise the best target to process, and most high-end custom profile practitioners will be able to offer this extra service for a small extra charge, maybe. Here we go. Now, when we've created our test target, we send it back to your paper supplier or your profiler with their requested information in full. So this is our finished test target printed out on the page, and we can write outside of these dotted lines what the printer is, any relevant information that the profiler needs, particularly if we produced more than one target and we're using different settings. So he needs to know absolutely what setting you've applied to this particular target. Now, this is our particular form, which covers Marriott.com and MarriottUSA.com, and we like you to fill out every little last bit of information here, because it helps us to properly serve you when we go further down the line. Now, the profile that we will actually create for you, we create the profile. In this case, the profile would read 3000 satin, 30th of the 4th, 14, because that's today's date. JRead, that would be me, .icc. So that would be the file name. 3000 satin 300414 jread.icc. The date identification enables us to confidently delete old printer profiles that may be in our system, because we don't want to end up with lots and lots of old redundant profiles. It's very easy to do. And also it reminds us when we need to check our print accuracy. So if we're using a profile that's obviously more than 6 months old, we know we're due to check our accuracy. And it's a good discipline to check ourselves on a regular basis. That's what differentiates us as professionals from enthusiasts. But incidentally, enthusiasts, again, it's good practice for them also. Now, it reminds you when to check your print accuracy. High-end studios, they have they actually check their profiling accuracy every month. Professional photographers check their profiling every 6 months. Using dated printer profiles helps you to keep an accurate guide on your process control. Now, I'm going to deal with process control shortly. Now, the next step is down to your profiler. Now, I show here a typical workflow screens from professional level custom printer profile software, which is connected, in our case, to an incredibly accurate calibrated automatic scanning spectrophotometer. Your profiler will input settings which will suit your particular paper and ink combination, make sure he knows every relevant piece of information. This means that you must fill out your information form which accompanies your test target fully, so he can accurately tailor your profile to your specific requirements. When your profiler returns your custom printer profile, usually via email, and they're usually very, very fast, we always endeavour to return our profiles by about lunchtime of the same day of receipt of our profile targets in the mail. You would then install your profile, you restart Photoshop, and then make ready your master test image. If you're not sure how to install your profile correctly, always ask your profiler. If you install your profile in the wrong folder, it will simply not work. Also at this stage, if you've forgotten to take note of your original target print settings, again, let your profiler know. For a professional photographic standard of printer profiling, we want to eliminate any element of guesswork. If you do not use exactly the same print settings as when you produce the test target, there is a chance that your finished prints will be slightly off datum. The care you take at this stage will be repaid by an accurate, consistent custom printer profile, which is a highly valuable asset. Now, step 6, you now print out your master test image, which you've got from your profiler. All profilers have a master test image. This is ours, and we can send you this accurate calibrated print in the post, and you can download this image either from marriott.com/print or marriotusa.com/print. You print out your master test image using your new custom printer profile, making sure that you apply the same printer settings as used when creating the printer profile test target. Also check that your inkjet printer nozzle check is perfect. Compare your new print created using your new custom printer profile against a certified correct version, which you will be able to obtain from your profiler. If the two prints agree, you may proceed to the next step. If it does not agree, contact your paper supplier or your profiler. They will happily fault find your workflow and test target and repeat the profiling exercise if necessary until your printing is perfect for colour, density and neutrals. So you can see here we've actually opened up our calibration image. This time we've gone to print in Photoshop. This time our dialog box, we are saying let Photoshop manage colours. We've selected our printer profile, which I'm sure you won't be able to read that. That is our R3000 printer profile. We use the same rendering intent, whether we have black points compensation collect or not. We click that on, and then we go to our printer settings, and we've been very careful to print out our proving image with exactly the same settings as we used for our printer profile test target. So again, we've got Epson Print Premium Glossy, we've got Super Photo 5760 in this case, and we've got our high speed on. We click print, and we want to make sure that the image that we produce agrees to the image that we issue you. We would send that to you free of charge over the post. Now, step 7 is we're starting to view our print. We take our final approved print created from our own inkjet printer using our brand new tested custom printer profile, and we place this next to our monitor, making sure that the print is illuminated by a suitable correct light source, a clean white light. If your monitor image does not agree to your print, which we now know to be accurate, we can now confidently adjust our monitor to agree to our print. So we've checked that the print is accurate, and we know it's absolutely correct for colour and density. We're now qualified to make the decision that either our monitor is accurate or not. Now, the method I use is to adjust my monitor contrast, then my brightness, and finally the red, green, blue sliders. Now I've got an illustration here of a typical PC monitor set of adjustments, and I'm able to select my brightness, my contrast, and then I adjust my three sliders. But when I'm looking at my print, I'm making sure that I'm looking at my print adjacent to my monitor, but I'm making sure it's viewed under a sensible white light. Now, our picture shows on the left a typical PC monitor screen adjustment. If you have an older Mac with an early version of Adobe Photoshop or Lightroom, you can also adjust your screen in Preferences for brightness, then go to Adobe Gamma for fine adjustment of colour and density. You can use the excellent step-by-step guide for this function. You can find this in the Help menu. The latest versions, however, of Adobe Photoshop and Lightroom do not carry Adobe Gamma any longer. And my solution for professional users is simply to purchase an on-screen calibrator, such as you see here. This is an I1 colorimeter. So that's an excellent piece of kit, and we show the typical screens that you will be shown when you put in the little bit of software that comes with this this on-screen calibrator. Now, the one we've used, as I've said, is the X-Rite i1 monitor calibrator, which can be worth its weight in gold in the long run. Now, a word about monitors. Many monitors which are provided as part of a computer package, particularly PCs, are simply not up to the job of rendering accurate professional photographic colour and density. If you can, budget for a high quality monitor, such as an ISO or similar make. Buy a good quality on-screen monitor calibrator and follow its instructions to the letter. This gets you in the ballpark for monitor accuracy. Finish the job by fine-tuning your colours manually until your image on screen agrees as closely as possible to your correct custom profiled master print. An on-screen monitor calibrator is unable to give you this final adjustment, as it is important that your monitor agrees to your custom profiled print according to your own perception of colour and densities. Our eyes are all slightly different, whether we're young, whether we're older, whether we're male or female. Pay particular attention to your neutrals and pale flesh tones. These are the most critical areas of your prints.